Module 4, Lesson 18, Writing and Evaluating Expressions, Addition and Subtraction. So far we have focused a lot on writing expressions, but now we are going to actually do a bit of evaluation. Alright, learning targets here. So we are going to continue to work on representing situations with mathematical expressions, but we are also going to start substituting. So we're going to make a move into these categories here. So we're going to do a little bit of experimentation with expressions, and we are going to vary the values in there and see what happens. So today, represent real-life situations by writing expressions that have variables, and we will be focused on the operations of addition and subtraction. And we want to use substitution to evaluate an expression for a given value. So we're only going to do one value, but this starts to open the door for us to be able to substitute in multiple values and see what happens. All right, so take a moment here and write an expression to show a number increased by 2. A little bit of a review here. So we would have some kind of variable, a number, and of course you could do just about any variable you wanted, and then we increase it by 2. And here we have a demonstration of the commutative property, although there's a part of my brain that says this is 2 increased by a number, which isn't quite the same as a number increased by 2, but thank goodness for the commutative property of addition, because we know that they will have the same value. And how could you show this with a model? So take a moment, think about that. How could you draw a model? Sorry about that. And hopefully you, in your mind, had a tape diagram going on or a number line, and you've got a box or a spot on the number line that is A with a 2. Tape diagram really works better than a number line because it's really hard to show a value on a number line. So we've got this generic expression here, this a plus 2. What is a real life situation that could be represented by a plus 2? So we have this very general situation, and let's see if we can think of a situation that would be represented by this. And an example that I came up with, we've got some students playing soccer. 2 more students join the game. How many students are playing soccer now? Well, I've got some students, and 2 more join the game. And not just any students, I have students playing soccer. Which brings us to an important discussion here. When we name the variables in expressions, it's very important to be clear about what they represent. We need to communicate with those individuals, those people who are looking at our expressions, and be very clear about what the variable stands for. Which means that we also need to be clear about units of measure. If we are measuring cups, or gallons, or quarts, or miles, or centimeters, or pounds, we need to be very clear about what is being measured. So looking through an example here, back to the real life situation I came up with here, how would we write up the variable? How would we express what the variable is? So in this case, the variable represents the sum students. So if we were to write this out as a sentence, we'd say the variable in this example represents the number of students that were originally playing soccer. And I'm going to pull that out, and I would actually name it as, let A represent the number of students originally playing soccer. So I'm stating here that I have a variable A, and then I am going to state what the A represents. And I am going to be very specific about that. I'm not going to have A represent the number of students because that's not true. The A is representing the number of students that were originally playing soccer. I'm not going to say that A represents the number of students playing soccer because that changes in this situation. I have some playing soccer and then 2 more join, so now I have some other ones playing soccer. So it's pretty detailed here. You need to be really specific about what it is that you're talking about. which in the first exercise, we're going to try and be a little more specific about what we're talking about. So we have a variable stated in the table, and we have an incomplete description. Somebody kind of did a halfway job on it, and it is your job to come up with a complete description. It says here, Joshua's speed. Well, if you will think back to some of the stuff that we did with rate, speed is a ratio of some kind of unit over some kind of time. We could measure speed in miles per hour, feet per second, inches per days. So this is very, very non-specific. We are going to want to get a little bit more specific about this. So think about some type of units that you could attach to this description and go ahead and write it down. And one possible answer here, let J represent Joshua's speed, and then we're going to get specific here. In meters per second. Now I have a speed. Now I have a unit of distance and a unit of time. So take a look here at Rufus's height. Let R represent Rufus's height. Well, are we going to measure that height in feet, inches, centimeters, paper clips? So clearly a piece of missing information here for our measurement. So go ahead and write Rufus's height, and let's get specific on our units here. For example, I could have R represent Rufus's height in centimeters. All right, take a look at the next one here. We've got milk sold. We've got the variable M, and let M represent the amount of milk sold. Well, in my head, I'm thinking, gosh, there's a lot of ways that milk is sold. It can be sold by the pint. It can be sold by the quart, the half gallon, the gallon. I was raised on a dairy farm. We sold it by the pound. So exactly how are we measuring the milk? We're going to do milk sold, and we're going to specify that it is in gallons. Oh, missing a number there. Let's say it's the 110-meter hurdles. Colleen's time in the 110-meter hurdles. Well, Colleen's time, well, are we measuring this in years? Weeks, days, minutes, hours, seconds, decades, millennia? So let's get specific. We're going to measure Colleen's time in seconds. All right, Sean's age. Let S represent Sean's age. And by now your brain should be screaming at you, hey, it's missing a unit of measure. And you might be thinking to yourself, well, it's years. Of course, everything's in years. Well, what if Sean is an infant, a baby? Lots of times those get measured in days, weeks, months. It's not usually got a couple of years under our belts that they will actually start to measure age in years. Frequently people will say, well, how old's the baby? And they'll say, oh, the baby is 6 weeks old. So evidently we are going to represent Sean's age in years. So the point of exercise 1 here is to really start getting us thinking about units of measure and how we are going to represent that when we declare our variable, when we set our variable out there. All right, exercise 2. So read the variable in the table and improve the description given, making it more specific. Well, in our head we're thinking, well, it's CDs. There's no unit of measure here. There's no length of the CDs. There's no height of the CDs. Well, we can get more specific on this. How about the number of CDs that she has? Or the number of CDs that she sold? Or the number of CDs that she gave away? Or the number of CDs that she would like to have? So getting specific here. What about the CDs? And this information can frequently come from within the real life situation you're looking at. All right, Josh's merit badges. Let J represent Josh's merit badges. Well, what about his merit badges? The number of merit badges he's lost, the number he still needs to earn, the number that he has earned. We're going to have Josh with the number of merit badges he has earned. So go ahead and finish up Rufus and the milk money there. Oh, looks like I made a mistake here. I'll have to fix that later on. So let's just work with the milk money here. Ooh, we'll scratch that out. All right, Rufus's trading cards. All right, let R represent the number of trading cards in Rufus's collection. And then the milk money, let M represent the amount of milk money collected in dollars. All right, so now working through some examples here. So on some of these, it's all done for you, so I can walk you through it, and then you're going to complete some on your own. So you're supposed to read each story problem, each real-life situation, and we need to identify the unknown quantity, and we are going to write an addition or subtraction expression that is described. And then we are going to evaluate the expression using the information given in the fourth column. So we're given some information here, and then we are going to substitute to determine the value of the expression. All right, it says Greg has $2 more than his brother Jeff. And we are writing an expression for the amount of money that Greg has. It's important that we read these carefully and determine what we're looking for. When we look at the second example on this, you'll see what I mean. So we've got a description here. J is representing Jeff's money in dollars. Now you might be asking, well, why didn't we write an expression for Greg? Well, to find Greg's money, we start with Jeff, because it says that Greg has 2 more than Jeff. So we are trying to find the amount that Greg has. So we have to work from Jeff to determine Greg. So J is going to be Jeff, and we know that we take Jeff and we'll have 2 more to get to Greg. So we have the expression J plus 2. And they're going to say, okay, if Jeff has $12, how much does Greg have? Well, here is our expression. Notice how they're showing the work here. And they've substituted in the 12. This 12 right here has come over and been substituted into our expression. 12 plus 2 is 14, and we know that Greg is $2 more than Jeff. So Greg has $14. All right, same situation. Looking at this next example, same situation here. Greg has $2 more than his brother Jeff. But in this case, we're going to think about it differently. The amount of money that Greg has. You know what? I'm pretty sure that's supposed to say Jeff. Yep, another typo. The amount of money that Jeff has. And so we are starting with Greg, and we are using the information to get to Jeff. So starting with Greg, and we want to end with Jeff. So I have Greg, and I know that Jeff has less money than Greg, so I'll take the 2 away. It says that Greg has $14. So I've got my expression here. Greg minus 2 is what Jeff has. And I'll substitute the 14 in. 14 minus 2 will yield a 12. So Jeff has $12. So you can see the difference here in these 2 problems is where we are starting and ending. In this problem, this first one here, we are starting with Jeff and ending with Greg. We want to know how much money Greg has. In the second example, we're starting with Greg and we want to end with Jeff. So we know how much Greg has, and we want to figure out what Jeff has. So we need to read these carefully and make sure that we're thinking about these problems and what's actually happening. All right, taking a look at the next set of examples here. Oh, yep, and I did it again. Got to work on that copy and paste there and make sure I read them carefully. All right, so go ahead and read this through. And there are a whole bunch of boxes for you to fill in here. And if I were you, I would focus on the first example that we have here. Oh, sorry about that. The first example that we've got. Boy, I'm just having all kinds of fun here. Let's see here. Get right back where I wanted to be. Aha, there we go. That's better. All right. So I would work on the first expression, get it all taken care of, check out what I put up there, and then look at the second expression. All right, so Abby read 8 more books than Kristen in the first marking period, and I am looking for the number of books that Abby read. So I am going to be working from what Kristen had to figure out what Abby read. So the description with units, this is where I write out my variable, and I'm going to say that K is the number, and I'm going to do some abbreviating, I've got a tight space here, of books Kristen read in the first marking period. And I know that Abby read more than Kristen, so whatever Kristen read, I add 8, and I will get Abby. And they're going to tell me Kristen read 9. So I've got Kristen plus 8, and I've got 9 plus 8, and I've got 17, and I have Abby read 17 books, and I'm going to run out of space here, but you should actually write out Abby read 17 books in the first marking period. So be specific there. We went through all this work to figure out the importance of the label. Let's use the whole label here. It doesn't say Abby read 17 books in the school year. It doesn't say Abby read 17 books last night. It's 17 books in the first marking period. And I would write that out, but I ran out of room. All right, taking a look at the second situation here. Abby read 6 more books than Kristen in the first marking period. And write an expression for the number of books that Kristen read. So I'm going to start with Abby, and I'm going to end with Kristen. So A is the number of books Abby read in the first marking period. Let's see if I can adjust this just a little bit so the pin isn't quite so big. All right, so, and it says here that Abby read more than Kristen. So Kristen read less than Abby. So whatever Abby has, I need less than that to get to Kristen. And it says Abby read 6 more. So I'm going to take what Abby read and reduce it by 6 to find Kristen. And then over here I've got my work. I've got Abby minus 6. 6, not B. There we go. And it says Abby read 20, so substitution. 20 minus 6. And 20 minus 6 will get me a 14. And so I know that Kristen, I'll abbreviate Kristen with K, read 14 books in the first marking period. All right, taking a look at the next example here. And you'll notice that I have added one that is not in your workbook, continuing, in my mind, trying to show the relationship between these expressions as addition and as subtraction. So even though it's not written in your book, if you wanted to, you could give this second example here a try. All right, Daryl has been teaching for 1 year longer than Julie. Write an expression for the number of years that Daryl has been teaching. So I've got Daryl is where I want to end up, so I'm going to start with Julie, and Daryl is 1 year more. Sometimes for me, it is helpful to write the expression and then come back and think through my description of the units. So let J equal number of years Julie has taught. And Julie has been teaching for 28 years. Oh, wait, first write my expression. There we go. Substitute 28 for Julie, J, and add 1, and I find out that Daryl has been teaching 29 years. All right, and I'll let you play with that second example there. All right, a few more examples for you to work through. I'm not going to write all of these out. If you want to see the answers, of course, you can go into the teacher materials and look them up and continue to look for this relationship between addition and subtraction expressions. You should notice for all of these situations that we are writing an addition expression and we are writing a subtraction expression, and depending on what is being asked, we will write addition or subtraction. So it's important that we think through what is actually being described in the situation. Really important. All right, closing. Why is it important to describe the variable in an expression? Stop and think about that for a minute. Maybe discuss it with a neighbor, somebody around you if you can. I hope that it has been made sufficiently clear here that we really have to describe the variable so we know what we're talking about. Being very specific. We need to know what it represents. If we don't explain the variable well, people are going to look and say, I know you've got a variable there, I know it's for speed, but I don't know what it means. I know you've got a variable there, I know it represents students, but I don't know what we're talking about with the students. And if we are measuring something, we have got to include the units. If something is being counted, include that it is a number of items, the number of students, the number of homework assignments, the number of days. All right, so how do we figure out if an expression will be an addition expression or a subtraction expression? Because we've looked at these in pairs. How are we going to decide if we are writing addition or subtraction? Well, this gets back to what I was talking about. You have to read the situation and ask yourself what's going on here. So in the first problem that we looked at, dealing with money, Jeff and Greg, we figured out that Jeff is where we were starting, and we are working from that to figure out Greg. So we started with Jeff, and we knew that Greg had 2 more. So it is defined as an addition expression because we are starting here at Jeff, and we are building up to get to Greg. Going the other direction, well, we were starting with Greg, who we know has more, and we were working to Jeff, so we were working down. So it is a subtraction expression. So the actual real-life situations will provide information for us to decide if we are adding or subtracting. All right, quick check on the I can statements. Represent real-life situations, representing addition and subtraction operations. Hopefully you can also clearly define your variable, and hopefully you can also substitute for a given value of a variable. All right, learning targets here. Once again, representing real-life situations using mathematical expressions, and then doing a little bit of work here where we're actually substituting some values in. So when values vary, we can figure out what's going on. We didn't do very much comparison, but we definitely worked with expressions varying. And then we did a little experimentation. So we actually plugged in some values with expressions, and we made some predictions about how much money or how many years, how much money someone would have, how many years they had taught. All right, that concludes Module 4, Lesson 18. So if you've got any questions, make sure you talk to your teacher. Go ahead and work your problem set.